We know that the integral from a to b of f of x dx typically is an area, and we know the double integral over some region of f of x y dA is typically a volume. And the triple integral over some ball of f of x, y, z dv is typically a four-dimensional volume, which is pretty difficult to conceptualize. But what if I go for the double integral over r of 1 dA? The double integral of 1 gave us an area. So if we extend that idea, we would say, again, the area of region R. If I had the triple integral of some ball of 1 dV, that would have to give me the volume of that ball B, of that region that we're interested in. So that's a fact that I want to use to find the volume of a sphere. So I want to use a triple integral to find the volume of a sphere with radius 5. So let's visualize that. So here's our sphere of radius 5. There's our equation, x squared plus y squared plus z squared equals 5 squared. And if we look at the projection into the xy plane, we see it's just a circle of radius 5. That will be our region of integration. But what am I integrating from? I'm integrating from the lower half of the sphere to the upper half of the sphere. Z ranges from the lower half of the sphere to the upper half of the sphere. So let's think what that would be. So again, we have our equation, which is x squared plus y squared plus z squared equals 25. And I want to figure out what that is as a sort of function, although it's going to violate the vertical line test. But what surfaces does z range from? Z squared is 25 minus x squared minus y squared. So z is plus or minus the square root of 25 minus x squared minus y squared. So we can see that z is going to range from what? Z ranges from negative root 25 minus x squared minus y squared to positive root 25 minus x squared minus y squared. So we get that, which is good. Now, how about x and y? What can we see about x and y? Well, we saw that this was on a circle of radius 5. So if we project that down into the xy plane, that would give me x squared plus y squared is 5 squared. So now looking for the southern boundary to the northern boundary, same kind of argument, right? It's 5 squared, of course. So y squared equals 25 minus x squared. So y equals plus or minus the square root of 25 minus x squared. So y ranges from negative root 25 minus x squared to positive root 25 minus x squared. And then once we do that, then we eliminate that as well. So now we're just looking at what's happening in the x direction. What's the smallest x I see? What's the largest x I see? This point is negative 5, 0, and this point is 5, 0. So x ranges from negative 5 to 5. But remember, the triple integral of 1 will be our volume. So let's consider that. So volume of the solid is the triple integral over that solid of 1 dV. So we need to determine what those ranges are going to be for us. So let's start with z. What does z range from? Z goes from negative root 25 minus x squared minus y squared to positive root 25 minus x squared minus y squared. Then how about y? What does y range from? Y ranges from negative root 25 minus x squared to positive root 25 minus x squared. And then what does x range from? X ranges from negative 5 to 5. And what is my dv order? It's really dz, dy, dx. So I have this, which you could imagine will be challenging to evaluate. So here is our model, and what I would like to do is I would like to convert this to cylindrical coordinates. And let me remind you how that works. We have points x, y, z, and we're going to rewrite them as r theta z. And what do we need to know? What are our key ideas here? So the ones we need for this problem is x squared plus y squared is r squared, and dA, which is dy dx, is r dr d theta. So dv, which would be dz dy dx, would be r dr d theta with a dz in there. So that's the information I'm going to need to fight through this problem. So let's see what we're going to get. So knowing that x squared plus y squared is r squared, that would tell me that root 25 minus x squared minus y squared, which is root 25 minus x squared plus y squared, would simply be root 25 minus r squared. So we'll make that substitution there. And we are hoping that this part here can be converted to r's and thetas once we look at the region. And then, of course, our dz, dy, dx is going to be r dr d theta with a dz. So now let's consider the portion out here. So x ranges from 0 to 5, and y ranges from negative root 25 minus x squared to positive root 25 minus x squared. So what we have here is we have a circle of radius 5. So if that's the case, what does r range from? What does theta range from? R goes from 0 to 5, and theta goes all the way around, so theta would go from 0 to 2 pi. So we should be able to make our substitution, so let's try it. So starting with this part, what are we going to say? 1 dz dy dx is going to be 1 r dr d theta with a dz. And now moving over, what do we have here? We said that root 25 minus x squared minus y squared was root 25 minus r squared. So I get z is negative root 25 minus r squared to positive root 25 minus r squared. And then we come back out here to r and theta. Typically, we go r first and then theta. What did we say r did? R went from 0 to 5, and theta went from 0 to 2 pi. R goes from 0 to 5, and theta goes from 0 to 2 pi. Remembering the volume is the triple integral of 1. Theta from 0 to 2 pi, r 0 to 5, z square root of 25 minus r squared to positive root 25 minus r squared. And this is the integral we have to evaluate. So the innermost integral is z from negative root 25 minus r squared to root 25 minus r squared of 1r dz. Again, focusing on the innermost integral. So the antiderivative there, of course, would be just rz, because r is perceived as a constant. Integral of 1 dz is just z, as z goes from negative root 25 minus r squared to root 25 minus r squared. So my integral becomes this thing, root 25 minus r squared minus negative root 25 minus r squared, which of course is just 2 times root 25 minus r squared times r, so that my innermost integral will be 2r times the square root of 25 minus r squared. So let's go ahead and substitute that. So we see the innermost integral, replacing it with our 2r root 25 minus r squared, dr d theta with those endpoints. So then the next thing I need to do is I need to determine what the inner integral is going to be. This is my inner integral, and I'm going to need to use u substitution again. So I'm going to let u equal 25 minus r squared. So the derivative of u with respect to r would be negative 2r. So du divided by negative 2r would equal dr. So we can go ahead and we can make that substitution for dr. So dr will wind up being du over negative 2r. And we see this guy is going to wind up being u. Now I also need to change my endpoints. So we said again, u is 25 minus r squared. So if r is 0, u would be 25 minus 0 squared, or u would be 25. So this is going to become 25. And if r is 5, u is 25 minus r squared, 25 minus 5 squared, u is 0. So let's make all of those substitutions and see what we get. So we have the inner integral is, when r is 0, u is 25. When r is 5, u is 0. 2r I'm going to leave alone. Root 25 minus r squared will become root u. And dr is du divided by negative 2r. And I'm very happy that the r's divide out. They need to. 2 divided by negative 2 is negative 1. So my inner integral becomes negative 1 times the integral as u goes from 25 to 0 of what, a root u du, or u to the 1/2 du. Now I don't like going backwards in time. Notice u goes from 25 to 0. I would rather change that order, but if I do that, that requires me to multiply by negative 1. So changing the order of integration, I get plus 1 times the integral as u goes from 0 to 25 of u to the 1/2 du. And what will that be for my inner integral? The antiderivative of u to the 1/2 is u to the 3/2 over 3/2 as u goes from 0 to 25, which is 2/3 u to the 3/2 as u goes from 0 to 25, which is 2/3 25 to the 3/2 minus 0. And what does that become? It's 250 over 3. So that is my inner integral. So now going back to the top of this page, everything in the middle there will be replaced with 250 over 3. So continuing with that idea, replacing that inner integral with 250 over 3, and I get volume is the integral as theta goes from 0 to 2 pi of 250 over 3 d theta. Now my only variable there is theta. We've lost the r's now. Each time we integrate, we lose a variable. Antiderivative 250 over 3 theta, as theta goes from 0 to 2 pi, which is 250 over 3 times 2 pi minus 0, which is 500 pi divided by 3. And recall what this was. This was the volume of a sphere with radius 5. And again, we believe that volume of the sphere with radius 5 is 500 pi over 3. But let's recall our formula from geometry. The volume of a sphere from geometry is 4/3 pi r cubed, in which case it would be 4/3 pi times 5 cubed, which is 500 pi over 3, agreeing with our answer from calculus.